Dum. Dum. Getting started. All right, I'm gonna get started. So I'm talking about rate in, rate out fricks today. Also graph fricks, table fricks, and particle motion fricks. So I'm gonna start off with rate in, rate out first. So let's do that. I don't know if I have the chat up. Can somebody like chat or no? Okay, I think I have it up. Okay, so we're gonna get started. Again, I'm gonna do rate in, rate out fricks first. That's the sort of the most famous first frick to start off with. The problem is I don't have a calculator, so I'm just gonna be typing in a lot of my answers into my computer here, but we can still get started. So let's say we have, let's see, what are we gonna do? We're gonna do the normal water tank situation. So water is leaking out of our tank at a rate of, let's say, let's do, we need a letter, we'll use W, e to the t minus 1, and then water is flowing in at a rate of, let's say, I don't know, R of t. And then we will start out like this. So it'll be sine t minus plus 1. So then again, this is a common rate in, rate out frick where you have a water tank, water is flowing into the tank, water is leaking out of the tank. We also have an initial amount, so let's put that as well. Let's say like 120 or something. Okay, so these are our givens for our fricks. We're given a rate in function, a rate out function, and an initial amount. So we're going to answer the 4 main questions, but before we get started, just be wary that sometimes the rate n is not given first. Most of the time the rate n is given first, but in this case, I like to start off with designating which one is my rate in and which one is my rate out. So this one is my rate out. And then this one is my rate in, because water is flowing into the tank, of course. Water is leaking out, that means that's the rate out. Okay, so this is where our FRQ is, and now we're going to get started with our questions. Again, just be wary that in, rate out FRQs on the AP exam, they don't always use the same words every single time. Sometimes they use different wordings. So for example, sometimes they'll say like, is the water level rising or falling at t is equal to 3 or something. So you have to know, unlike particle motion where they'll just use explicit words like total distance or speeding up, slowing down, and they use the same words every single FRQ, because it's a real world situation when we do these rate in, rate out FRQs, you just have to be slightly wary that they're not going to use the same exact words every single time. So it's nice to know how each question deals with amount, because amount is the big question when you're dealing with rate in, rate out FRQs. So in this question we have, is the water level rising or falling? Well, what is water level? Water level is rising and falling would just be the amount of water in the tank. So another way to phrase this question is the amount increasing or decreasing? So I always do my increasing, decreasing question the same, and I'm going to do it as I'm about to do. So I always like to locate the function, which is the amount, because I want to see if amount is increasing or decreasing. So what I do is I find the amount formula. And the way this works is that the amount formula is always going to be the same. It's always going to be number plus integral. It's the fundamental theorem of calculus. So amount equals the initial amount, which is 120, plus the integral is 0 on the bottom, t on the top, and then it's rate in minus rate out. Again, just be wary that rate in is the second one given and rate out is the first one given. So we're going to use R. We're going to use the letters that are given. And also be wary, this is something that teachers like to count off a lot, is that we want this top variable to be t here as opposed to x's. So when we put our integral, which we're about to do, we're not going to call it sine t plus 1. We're actually calling it sine x plus 1 or r of x, because we don't want this variable to match this variable. Because when we plug in numbers, we're only going to plug into the top. Same thing with this, the rate out. We're going to do rate in minus rate out. And again, these x's, again, don't match this t. So hopefully this makes sense of our construction. I like to find something, and then I'm going to take its derivative. So this was the finding part. I found the amount, number plus integral, and now I'm going to take its derivative. So what's the derivative of the amount formula? Well, let's take the derivative carefully. What's the derivative of 120? That's 0. What's the derivative of an integral? That's fundamental theorem of calculus again. All you do is you plug in your t. So notice we'll get rate in minus rate out. And if you look at the answers that College Board provides on their AP exams, they will go straight to this step. But again, I like to always do my questions the same. Find something, take its derivative, see if it's positive or negative. Let's write greater than or less than here. So then all I'm going to do is I'm going to plug in 3 now into my derivative. So if you have a calculator, now is the time to try it. You're just going to plug it into the calculator. So I'm going to get r of 3 minus w of 3. And again, because I don't have a calculator with me, I'm going to have to type this sort of by hand. So give me 1 second. X equals 3. Notice that because I'm taking a derivative, even though I'm taking a derivative, I'm not actually taking a derivative with a calculator, because the derivative was already the givens. So this number is supposedly, according to this computer, it's supposedly negative 17.944. What's the relevance of this number? Well, this is a negative number, of course, so that means that my amount's decreasing. So that's how I like to find every single increasing, decreasing question. I like to find the thing, and then I like to take the derivative, and then I'm going to see if it's positive or negative. Here, the derivative happens to be given, because the derivative of the amount formula is just rate in minus rate out. So that's how you do these questions. Let's move on to the second question. Let me know if you have any questions in the chat. So we're going to do, what am I doing? We're going to do find how much water entered the tank from t is equal to 0 to t is equal to 2. So again, this is a pretty common question. In these rate in, rate out fricks, you want to know, are they asking me to take a derivative? Are they asking me to plug in a number? Are they asking me to take an integral? So how much water is an amount? And just keep in mind, there's two main amount questions. One is the amount accumulated over a time period, and then one is at a time. So this one is the less common question. This is over a time period if you can't recognize it, because it's how much water entered the tank from t is equal to 0 to 2. So when you have this amount over a time period, remember that you don't add the initial condition of 120. So I'm just going to start with this answer. All it is the integral. I'm going to write it over here on the side if you can see. It's going to be the integral of just rate n, because we want to see how much water entered. And then the rate n is this guy right here, r of t. And then you just put the time period, 0 to 2. And then you just type this in a calculator. So it's not too bad. Let me actually type this in a calculator real quick. If you are typing in a calculator, remember to be in radians, because on the AP exam you're required to be in radians, and you don't want to miss easy points because you're not in radians. So I'm just typing this in right now, 0 to 2, and I'm going to get 3.4161. So amount over a time period is a pretty easy question. It's just the integral of either rate in or rate out. You don't add the number, and you just type the integral as carefully as possible into your calculator. Just be wary that sometimes they ask you to round to the nearest whole number, which you would want to do, of course. But these are the two sort of easier questions on these rate in, rate out questions, or the two lesser important questions, where you want to see if an amount is increasing by taking a derivative, and also if you want to find how much came in or how much left. So now I'm going to do the bigger question, which is amount at a time. So let's do that. I'll just cover up the paper here. So C. So C is, let's find the water level at t is equal to, I don't know, 3. Okay, so now we're doing this question. This is the most common question. If there is a rate in, rate out question, there will definitely be this question on the AP exam, because this is the fundamental theorem of calculus. Again, they might not use the word amount at a time, but you should recognize that the water level means the amount, and we're doing it at t equals 3, so this is at a time. So this is number plus integral. This is our favorite sort of formula to use in all of calculus. So it's going to be a of t. We actually already wrote it for our increasing decreasing question again, but let's rewrite it again. So a of t will be the given amount, which is 120. Then I'm going to put a 0 on the bottom because that's the given time. And rate in, rate out, the given time is usually 0. And particle motion, it might not be 0, so we'll practice that later. Then we have a t on the top. Finally, we do rate in minus rate out. And again, I want to leave my variables different as I do this. So it looks like r is my rate in, so it's going to be r minus w, rate in minus rate out. And again, just be careful. I have these variables not matching. This is t on the top, and these are x's within. So now I'm actually done with my formula. Some people like rate in, rate out questions. Some people like particle motion questions, because as long as you know the formula, you should be good to go. So how are we going to use this formula? Well, if we want to find the amount of water at t equals 3, we're just going to plug in 3 into this formula. So it's going to be 120, 0 to 3, r of x minus w of x. And that is going to be our thing we're going to plug into the calculator. Of course, the calculator doesn't know what r and w is. On the AP exam, you can leave it with r's and w's because those are the letters that were given in the question. But when you type in the calculator, you do want to change them to what the functions they actually represent. So I'm going to do that again in my calculator. So give me 1 second. It'll be 120 plus integral of sine x plus 1 minus e to the x minus 1. And the integral is from 0 to 3 because that's our time period. 0 to 3. So we get 108.904, I believe. Hopefully you can see that. Just a few things to be wary of when you type it in a calculator. The key is, first off, don't forget to add the 120. Some people like to type the integral in and then add 120. Some people like to do it on all one fell swoop. Whatever you do, just don't forget that 120 at the beginning, which occurs when you have amount at a time and does not occur when you have amount over a time period. Secondly, when you're typing in the calculator, just be careful with parentheses. So I always put my rate in all in parentheses and my rate out all in parentheses. So what I just typed in a calculator or my computer here was 120 plus 0 to 3 rate in. So I'm being careful with parentheses. So notice I'm putting the rate in parentheses, and then I'm also putting the rate out in parentheses, and I just typed it in. So just be wary of that if you're actually practicing typing in the calculator. Okay. So that's, again, a very common question, probably the most common question. The second most common question is the one we're about to do, and it is find the time when the water level is greatest or least. Again, what most students struggle with the most is trying to recognize sort of how to start the question. And again, in particle motion, or not in particle motion, in rate and rate out, unlike particle motion, they might not use the same words that you're used to. So greatest, if I were reading this question, I read greatest, and greatest has a superlative, EST. So this means abs, max, or min. So I'm gonna write abs, max, or min. So abs, max, I don't need this slash here, abs, max, or min. And how do you do abs, max, or min? Well, that's a three-step process. So no matter where the abs, max, or min question occurs, and usually it occurs on maybe 2 of the 6 FRQs on the AB exam. It can occur in particle motion and occur in rate and rate out, which is what we're doing right now. And it also can occur in graph. Those are the 3 main ones. Sometimes even in area and volume. But for now, we're going to do this rate and rate out question. You're always, no matter where it occurs though, you're still going to do the 3 steps as follows. The closed interval method is what some people call it. The first step is locate the function. And sometimes this locate is very easy, this step right here, because the function is given. But in this case, it's not given. So we have to first find it. But in rate in, rate out FRQs, it's going to be the amount formula because we want to find the time when the water level is greatest or highest. So it's the same formula we've been talking about earlier, this number right here. So it's going to be 120 plus 0 to t of r of x minus w of x. We actually should have an interval. So let's say find the time between 0 and 3. So let me put that at the end. So between 0 and 3. Because we're doing the closed interval method, so we need endpoints. Okay, so we're doing abs, max, or min again. I located the function. What some students mess up is that they'll already plug in 3 into my t here, but I want to keep this as a function. So I'm not going to plug in my 3 yet. I'm going to plug in my 3 eventually into the table. So I'm going to proceed as normal. The first step is locate the function. Even if it's trivial, I like to write down the locate because it's easier to take a derivative if it's already in the page. And I'm going to take a derivative because that's what the second step is, critical points. So you're going to take the derivative of the amount, so it's a prime. Derivative of 120 is 0, and the derivative of this integral, which we already did, is rate in minus rate out. Because when you take the derivative of this integral, basically the derivative and the integral cancel out. So then I have this function right here. Keep in mind that this second step is not really derivatives, it's critical points. So we're going to set this derivative equal to 0. And now we're going to type into a calculator and try to find these zeros. So let me do that real quick. So roots of, I believe, according to this thing, it doesn't understand what I'm saying. So let me try it again. Okay, so it seemed to work now, and I got 1.054 as my one critical point. So keep in mind that you won't be able to type into a laptop if you're going to be taking this as a test or as an exam. So some people like to sort of describe what you would have to type in a calculator. First off, when you're trying to find these zeros, you have really 2 options. Depending on what calculator you have. Everybody has the option of graphing, and that's sort of the intended strategy in my opinion. But some people like to use the solve button if you have an Inspire, so I'm going to write that down. So what I'm about to write down is what you would have to type into a calculator to find this 0. So it'd be solve. And then you do rate in minus rate out. You can't use R's and W's, of course, because the calculator doesn't know what R and W is. So I'm going to use signs and the sine function and the e. So it'll be sine. Again, I'm going to plug in t because it's rate in minus rate out with t's. So it's going to be sine t minus 1. Notice I'm being careful with my parentheses here as I put rate in parentheses, and I also put rate out in parentheses. I'm going to set this equal to 0 because, again, it's critical points as opposed to just taking the derivative. When you're using the solve button, remember that you need comma the variable, and then you need this vertical bar thing because sometimes when you have trig, you won't understand what the calculator is telling you in terms of the numbers. So it'll be 0, t, and 3. And this is what you're typing into a calculator, and supposedly you will get t equals 1.054. Now with unit next, well, this is my favorite step. This is the table step. So you construct a table of function values for your locate function. And what numbers are you going to plug in? Well, you're going to plug in 3 numbers. You're going to plug in the endpoints, 0 and 3. And we're plugging in 3 numbers because there's only one critical point that fits within that endpoint for this particular question, which is 1.054. And then some people ask, where do you plug in these numbers here? Hopefully you can see these numbers. But you plug into the locate, which is why we write the locate down. So when I plug in each of these numbers individually, I'm going to change just the top and like replace 1.054 with this number, 3 with this number, 0 with this number. And I don't plug in the number over here because that's why we changed our variables in the first place. When you plug in 0, notice you'll get 120 because that's the initial amount. And theoretically, your error carries when you do these FRQs. So I already did A of 3 in the previous question, finding the water level at 3. So I'm going to use that number as well. Looks like it's 108.904. And then we only have to do one more number, which is 1.054. Let me do that real quick into a calculator. As you're doing this, remember to still add that 120 at the front because we have to add the initial amount. So according to this, I get 120.745. So that is actually going to be our greatest amount, and we're trying to find the greatest here. So t is equal to 120.745. That's when the abs max is here. Abs max. Let's be careful here. The 120 is the y value, so the abs max is this number, and then some people like me do know when the time occurs, and notice it says find the t, so we're going to write that down too. Not my best work, but again, abs max is the biggest y value in this table, and it occurs at this t value. So hopefully that makes sense for rate in, rate out. This is how rate in, rate out works, where you have these 4 main questions. You have increasing, decreasing amount questions. You have amount over time, which is just the integral. Then you have amount at a time. That's the most common question. That's at the C, where you do number plus integral of rate in minus rate out. And then finally, you have abs max or min, which usually you locate the amount at a time formula. But that's rate in, rate out. If anybody doesn't have any objections, I'm going to move on to the second FRQ here, and the second FRQ being particle motion. So let's do that. I think we can go on. Okay, let's do some particle motion. So I'm going to move this aside. So I like particle motion the best. It's my favorite AB FRQ. I think it's the easiest one. It really is the easiest one when you're given a calculator. It becomes one of the hardest ones when you don't have a calculator because you have to take derivatives and integrals by hand. But statistically, usually it will be a calculator FRQ, one of the two. So let's practice that. In a particle motion question, you're given 2 givens always. You're given a velocity. I'm not going to make this too crazy because I didn't really test out numbers today. So let's do sine of t squared or something plus t, whatever. And then you're also given an initial position. So let's say at t is equal to 2, the position of the particle is 1. Okay. So these are our 2 givens. Keep in mind that these are actually the same 2 givens as our rate in, rate out. When you have a rate in, these givens match rate in, rate out because you're given a rate. So in rate in, rate out is a rate in minus rate out. And then this one is velocity. and you're also given an initial position. Again, in rate in, rate out, usually that initial position, initial amount is at 0, and in this case, it is not. It's going to be at t equals 2. Okay, but let's just do some of the questions, the main questions. So my first question I'm going to do is I'm going to find when is this particle speeding up or slowing down. At t is equal to, let's say, 2. So again, particle motion is knowing all about knowing rules. Do you know what speeding up and slowing down are, or do you know what moving closer away, stuff like that? So let's get started here. Anytime you're going to use a rule, you have to write down the rule. So I like to start off with that. So a particle is speeding up when the velocity and the acceleration have the same signs. Same signs. And a particle is slowing down when velocity and acceleration have different signs. Slowing down when velocity and acceleration have different signs. Meaning one's positive and one's negative. So just be wary that sometimes they don't use the word speeding up, sometimes they'll use the word speed increasing, sometimes they don't use the word slowing down, sometimes they use the word speed decreasing. But either case, you do the same thing each time. We're going to find v of 2, and then we're going to find a of 2. Well, how do we first find v of 2? Well, keep in mind that velocity is given, so to find v of 2, all you're going to do is you're going to plug in 2 into this formula. So let me do that into my calculator here, and by calculator I mean computer. So 2 squared plus 2. I'm gonna get negative 0.270 supposedly. So when I did this into a calculator, all I did was I plugged in 2. Acceleration will be slightly harder because acceleration isn't the given function. So keep in mind it'll be involve a little bit more work. Here we're going to take a derivative. And if you want, you can take the derivative with a calculator. Or sorry, by hand, this derivative isn't too bad. But I'm going to use a calculator because we have the option of calculator. Just keep in mind that if you're using, for example, an Inspire, I don't use the derivative function on the calculator. I use derivative at a point because we want to find the derivative of v at 2. So I'm going to have this function right here. I'm going to take the derivative at 2 using my calculator. So let me do that real quick. Derivative of 3 sine of x squared or t squared plus x at x equals 2. And supposedly this number, give me my calculator some time to do its magic. You got it, buddy. I get 1 plus 12 cosine 4. Obviously, I want that as a decimal. And they say it's negative 6.843, supposedly. Okay. And then these two numbers, really, remember, are not really relevant in terms of how big they are. It just matters whether they're negative or positive. Notice both of these numbers are negative, so that means our particle is speeding up because they have the same sign. So our particle is speeding up. This is usually the first question on these particle motion questions, and usually it's only worth 2 points, maybe 1 point, because it's a pretty quick question. You just plug in to find the v, take the derivative, plug in, take the derivative for a, and then you just see if they have the same signs or different signs. Okay, so moving on to another question. Let's do total distance now. So total distance of the particle from t is equal to 0 to t is equal to 3 or something. So total distance is one of the easier questions when you have a calculator because all you have to do is set it up and then type it in a calculator. The key is that when you're doing total distance, just be wary that it's 0 to 3 or whatever your time interval is, and it's the absolute value velocity. And the absolute value velocity is speed. So another way to say this is that it's the integral of speed. So I'm going to write this down, 0 to 3. I'm going to write v of t. I guess I'm writing the same thing. If you want, you can type it in a calculator here. So let's rewrite this. It's the absolute value of 3 sine of t squared plus t. Close the absolute value bars, and then we're going to write dt. So just be wary that when you're typing this in a calculator, the absolute value goes inside the integral and not outside the integral. Give me 1 second as I type this into my calculator. Integral of absolute value. So I need to remember the absolute value, and I need to put it in parentheses. 3 sine of x squared plus x. Close those parentheses. And then we're going to go from 0 to 3, because that's our endpoints. So notice how easy this is. I just remember a formula, and I just apply the formula. Letting my calculator do its work. It has no idea what I'm talking about. That's embarrassing. Come on, you can do this, Wolfram. Okay. I don't want to find this root. Okay, according to this, it says 7.211, so I'm going to assume that's the answer. But again, all you do is you just write integral of the absolute value of velocity, and then you just find it. There's no really thought involved as long as you know your formula as well. All right, let's keep going then after total distance. So we're going to still use these two givens. But let's do average velocity. So C, this is C. Find the average velocity from t is equal to 0 to t is equal to 3. So if you don't know, there's two formulas for average velocity. One is 1 over b minus a, the integral of velocity, because the average of anything is 1 over b minus a, the integral of that thing. You can take the antiderivative of v, and that's position. So another way to phrase this is s of b minus s of a over b minus a. So these are the two formulas for average velocity. So the question is, which formula do I use? Well, you use this formula when velocity is given, and here velocity is given because velocity is always given in particle motion frics. And you use this formula when position is given. So this is more like a multiple choice question, so I'm not going to use this one. So all I'm going to do is I'm going to type into a calculator this formula when I put up 0 and 3, and then this function. So it's going to be 1 over 3 minus 0, which is just 3, integral of 0 to 3, and then I'm going to put in this function here, 3 sine t squared plus t. So it should be 3 sine t squared plus t. And again, give me 1 second as I actually type this in a calculator. But hopefully you notice that in these particle motion questions, I'm not really thinking at all because I just know these formulas. I've done these questions enough where I can just see the words and then I just know what to do because I have a formula that represents each question. Like average velocity, total distance, speeding up, slowing down. So there's not much thought involved after you practice enough of these. Where in other questions like that rate in, rate out question, sometimes you do have to think about what they're asking. So this is just 2.273 according to Wolfram. And that's how you do average velocity. Average velocity, keep in mind, is not the most common question in these particle motion questions, but it does appear every once in a while. So the next question I'm going to do is, I'm going to find when is the particle farthest right. Give me 1 second as I do this. Let's see, what time period do we need? Root. Okay, so that one doesn't exist. Does this never equal 0? That's not good. No. Sorry, 1 second as I try to find these zeros. What's this number from? This is why you should prepare good functions. Okay, there's definitely a 0 here. What is it? Give me one. Okay, so let's just say from 0 to 3, and we might get the numbers, we might not. So let's start this. So anytime you're doing farthest right, you want to do the 3-step process, abs, max, or min. So its first step is to locate the function. And here we have to decide, what do we want to locate? Is it going to be position, velocity, acceleration? Well, farthest right implies that we're trying to find the abs max of position. So we're going to locate that. And just like with rate in, rate out, when you do the finding the SAT is the antiderivative of V, and how you're going to write it is you're going to use fundamental theorem of calculus. We can't do the plus C method because we're not going to be able to take this integral. So it's going to be the initial condition. And let's look at the initial condition here. At t is equal to 2, the position is 1. So anytime I'm doing these questions, I like to be very, very careful on what my coordinate points are, because if I mess this up, I mess up the formula. So I have to think in my mind, do I want it to be 2, 1 here? Or do I want it to be 1, 2 as I set up FTC? But in particle motion, time is always the first coordinate because time is the independent variable. That's the variable you're plugging into this velocity, for example. So it's going to be t at is 2. So this is going to be my point. And how do I use this point to construct my FTC? Well, when my locate function right here, I do number plus integral, and I always add the second coordinate, so I'm going to add 1. So it's going to be 1 plus 0 on the bottom. I'm going to, again, just not 0 on the bottom. Let's actually be careful. The given time is 2, so unlike rate in, rate out, this is 2. It's always the given time value. And then we're going to write our function, so velocity. So our velocity is right here. So it's 3 sine x squared plus x. And why am I changing these to x's? It's because I don't want these to match. I don't want my variable t to match with my variable x, because when I plug in numbers, when I do the table, I'm only going to plug into the top here. So my second step is my critical point step, and that involves taking the derivative. What's the derivative of 1? That's 0. What's the derivative of the integral? Well, it's just plugging in the t. And of course, s of t is the derivative of st is going to be v of t, what we started off with. So it's going to be 3 sine of t squared plus t. We're going to set it equal to 0. Let's see if I can make this work now. 0? How does Wolfram Alpha want me to find this? I don't want to plot that. Zeros of... Come on, you can do this, Wolfram. Okay. I need to learn how to use Wolfram more easily, but we're trying to find the roots here. So I don't know what the roots are, to be honest. They say it's 2.3. I think there's another one, but let's just assume that there's this one right here. What is that other one, though? Oh, it's 1.9. Okay, we're actually good. Okay, so these are our two numbers. Again, I use the calculator. There's 2 ways to do this. You can type this in a calculator with a graph, or you can use the solve button. So now that we have these times, let's construct our table. So third step is constructing a table, t and a of t. So we're going to plug in our 2 endpoints, of course. That's going to be 0 and 3. And then we plug in the critical points that fit within our endpoints. So my calculator gave me a lot of zeros, but these are the only 2 that fit within our 0 and 3. So we're going to put those down. And then now we're going to take each of these numbers individually and plug it into this formula right here. So just be careful as we do this. Now it's time for our calculator again. So let's do 1 plus integral of 3 sine x squared, or t squared, from x is equal to 2. So keep in mind our bottom number again is not 0, it's 2. So when we plug in 0, we're not just going to get 1. I didn't put a parenthesis. So when you're typing in a calculator, you want to be careful with your parentheses, typing it in incorrectly. A lot of students do mess up that step, but supposedly you get negative 3.41433. And when you're typing in the calculator, it can be quite annoying, of course, and you might be thinking, oh my gosh, I have to type this in so many times. But really, after you type in the first one, you're just changing the top number, so it's not too bad. I'm going to keep plugging in my numbers. Now I need to plug in 1.963 into the upper limit of my integral. That's going to give me 1.00506. Then I'm going to plug in 2.323, which is my other critical point. 2.323. So that is 0.806. And then finally, I'm going to plug in 3, which is my endpoint, because I always plug in my endpoints and then any critical point that fits within my endpoints. And I get 3.406. So this is going to be my abs max, because if you look at these 4 numbers in the table, notice that this is the biggest one. So my particle is farthest right at t is equal to 3. And what is the farthest right position? Well, it's going to be 3.406. And after all of that, that is how you do particle motion. There are some questions that we didn't talk about in particle motion. I think the easy thing about particle motion is that you just need to know the rules. The hard part is that there's a bunch of rules. So we did speeding up, slowing down. We did total distance. We did average velocity. We really did FTC as we constructed this table. And then we also did add, max, or min. Other questions that are going to appear are like moving closer or away, which is when you find the position, and you also find the velocities and see which way each position is going by those velocities, the sign of the velocities. Another common question is like, when is a particle at rest? That's when velocity is 0. When is a particle moving forwards? That's when velocity is positive. When is a particle going backwards? That's when velocity is negative. And then they also ask speed questions. Speed is the absolute value of velocity, so usually you're plugging in 2 or setting it equal to 2. Like if you're finding the speed at 2, you plug in 2. If you want to find if you want to find what time the speed is 2, you set it equal to 2. But if nobody has any objections, I'm going to go on to table fricks, and I want to hit every frick if possible. So I'm going to do that. So let's do that. So let's get rid of these old sheets. And table fricks sometimes are calculator and sometimes are not. Really, the only thing that the calculator is telling you to do is to do Riemann sums or slopes more easily. But I'm going to assume that we have a calculator just to make my life a little bit easier. And then for this table frick, because in AB, particle motion is so important, half the time table fricks are just particle motion questions. So I'm going to draw a table, and I'm going to do all my table in the context of particle motion. So I'm going to have this table right here. Sometimes they'll like use like situations of like somebody riding their unicycle on a track or whatever. But I'm going to keep it the most basic. I'm just going to call this T, call this V. Let's put this in seconds. Let's put this in meters like normal. And I'm just going to do random numbers in this table. So let's do 2, 6, 8, and these numbers got too big. 9, and then let's do -3, 4, 1, and 8. Or no, we already did 8, so let's do 7. All right, so this is my given table. And then we are going to answer the following questions. So the first question in these table fricks is usually approximating a derivative, which in this case is a. So they'll say like approximate a of 7 with correct units. Indicate units of measure is what they say. So when you're approximating a derivative, well, a derivative is calculus slope, but you're approximating it. You can't take the derivative of something in this table. So you do the next best option, which is use algebra slope instead. Y2 minus y1 over x2 minus x1. The question is what columns to do, and you choose the columns that 7 fits within. So notice this is 7. 7 is in between 6 and 8. So this is going to be my algebra slope, or what 2 columns I'm going to do my algebra slope on. Just keep in mind that the top row is the x's or the t's, and the bottom row are the y values, which in this case are the v's. So it's going to be v of 8 minus v of 6. Again, I chose 7 because 7 fits between 6 and 8. But I'm doing algebra slope now. V of 8 is 1, it looks like. So this is where my table comes into handy. And it looks like I get negative 3 halves. I don't really need a calculator for that. Again, a lot of students struggle with units. Anytime you're taking a derivative is a rate or a slope. So what you do is you take your current time and then you divide by a time period. So this probably shouldn't be in meters. This should be in meters per second, of course. That's how velocities are usually. So if our table was right and it was meters per second, what should be the unit of our acceleration? Well, that will be meters per second squared, because you take your current unit and then you divide by time, or meters per second per second. If they ask units, you do have to put units on the AP exam. If they don't, you don't have to. Just be careful with units, because that is often the trickiest part. Okay, second question. Let's approximate total distance, which is this formula again. So it's the integral of the absolute value of velocity. The integral of just regular velocity without the absolute value is total displacement. But in this case, we're doing total distance, and we're going to go from 2 to 9, which is just the entire table. And we're going to approximate it using a trapezoidal sum. So that's the hardest sum. So let's practice that. So whenever you're doing a Riemann sum, left, right, trap, or midpoint, you just start doing the Riemann sum. And the Riemann sum is the approximation of the integral. Anytime you're doing these Riemann sums, just remember that what doesn't change is that it's always the difference in the top rows when you're doing two adjacent columns, and then you multiply by different y values. So it's always going to be like 6 minus 2, and then I'll either multiply by negative 3, multiply by 4, or the average of the two. If it's midpoint, you would group them up into trios, but it's always the difference in the top row. Trapezoidal is, of course, the hardest sum, and how it works is you do the difference in the top row. So let's start that, 6 minus 2. And then instead of choosing the left number or the right number, you're going to do the average of the numbers. Another big thing in this question is notice that we're doing the absolute value of velocity. So even if this value is negative here, we have to treat it as positive. So that's how the absolute value comes into play in this question. What you do is you have to account for all the velocities being positive, even if there's a negative, and you don't do that at the very end. You do that individually because the absolute value is within the integral. So when I do my trap sum, instead of multiplying by negative 3 plus 4 over 2, because it's the average of the two y values, I multiply by 3 plus 4 over 2. The next ones shouldn't be any trickier than all the that one, because there's no negatives here. But it's going to be the difference in the x's, so it's going to be 8 minus 6. And then instead of doing 4 or just 1, we do the average of the two, so 4 plus 1 over 2. And then final trap is 9 minus 8, which is 1, times 1 plus 7 over 2. Because again, it's the average of those y values. Now I'm going to just simplify this. 4 times 7 over 2 plus 2 times 5 over 2 plus, looks like this is 8 over 2. I don't like doing sometimes the divide by 2's because everything gets divided by 2. So I like to have the common denominator already of 2 set up. So it's going to be 28 plus 10 plus 8. Again, this could be calculator as well. 28 plus 10 plus 8. That's going to be, I can't do math right now, 28, 38, 38, 46, I think, over 2. Well, that's 23. So this is how you do trapezoidal sum. Again, the hard part is A, trapezoidal sums are more annoying because you have to introduce this fraction. And then B, we had to be careful with the negative. We had to treat it like positive because we have absolute value. But that's how you do trapezoidal sums. So now let's do this question right here. So C is going to be y must A of t equals, y must A of t equals 6 for some t in between 8 and 9. So this is my next question. This is also a pretty common question when you're doing these table fricks. And anytime you have a weirdly worded question, why must something exist? Show why something exists, as opposed to just finding a derivative or an integral. This is going to be IVT or MVT, because IVT or MVT are the two theorems in calculus that we use to show the existence of answers as opposed to find the answers. And one thing you have to ask yourself is this going to be IVT or is this going to be MVT? Well, it's based off the relationship between the function and the function in the table, the given function. And because A is the derivative of the thing on the table, this is going to be MVT. So let's do MVT. I always just write by MVT. And then I start doing algebra slope because MVT says the calculus slope equals the algebra slope somewhere in the interval. Also, I like to use their columns, 8 and 9, so that will be what I construct my algebra slope from. So it's going to be V of 9 minus V of 8 over 9 minus 8. That's again going to be 7 minus 1 over 1, which is 6. And so that's 6. And remember that when you're doing MVT, you need this number to match this number perfectly. Then after you do that work, that is basically the work. So then you just say there is a time 6. There is a time that A of t equals 6. So there is a time A of t equals 6. Where t is in between 8 and 9. So that's how MVT works. I'm running out of room here, so I was going to do IVT sort of slanted. Forgive me, but I'm going to do IVT like on the side here. So let's do a question about IVT. Why must V of t equal, let's see, look at my table. Let's do 0 for some t in between 6 and 8. Sorry. For some t in between 6 and 8. Okay, so here's my table. And again, I have to recognize whether I want to do IVT or MVT in this question. But because V is given and V is in the table, this is an IVT question. I'm going to use my columns 6 and 8 because those are the ones indicated by the question. And remember that the most important word is the word between. So you just take this number right here and you just say that it's in between the y values of those tables. Of course, 0 is not in between 4 and 1, so that's a bad number. Let's do 2 instead. Okay. When you take the AP exam and when you take tests, you hopefully the questions are valid. So let's start this. Why must V of t? So you should say by IVT because 2 is in between V of 6 and V of 8. So I'm going to write V of 6 equals 4 and V of 8, which is 1. V of 6, which is 4, and V of 8, which is equal to 1. There is a time. There is a t where V of t equals 2. So this is a pretty typical table fric. They asked some sort of approximating derivative question, which is algebra slope. They asked some sort of Riemann sum. And then they asked IVT or MVT questions. And those are the main 3 questions on these table frics. Again, this entire table fric was in the context of particle motion, but that's just how it works sometimes. Okay, so that's 3 frics down. That is rate in, rate out, table, and particle motion. I was going to do one last fric, and that's going to be graph. Graph is my favorite fric maybe because you don't have to do much math on it. It will probably be non-calculator because you can't really type in a graph into a calculator. So let's just draw a random graph. Let's keep it simple for now because it is a Sunday. So let's do 1, 2, 3, 4. Just making up a graph here. When you do these graph frics, just like with particle motion, it's all about knowing rules, like concave up or down rules and things like that. They can't get any more difficult. Let's go up to again. These graph frics, I'll just cross 2 here. And then let's cross. Is this right? I went down to rain 1, went down to rain 1, went down to rain 1, went down to rain 1. Go down 2, go down 2, go down 2. Okay, sure. This is going to be my graph, not the prettiest graph I've ever written. Okay, yeah, so this is my graph. This is a graph of f prime. F prime is always given in these graphs unless you have the variation where g is an integral of f and the graph is f, but that's basically the same thing because g prime would be f here. So this is my f prime graph. They'll also give you an initial condition when it's this variation, as we'll see later. So let's just say f of 0 is equal to 6. Some students get confused because if you look at this graph, even if it's not very pretty, they'll be like, oh, 0 is not 6, so how does this work at all? Well, again, this is a graph of f prime, so that's why it doesn't go through 0, 6. These are both givens. So I'm going to run through the main questions here. Let's do the first question that is normally asked. Let's find f of 1, 2, 3, 4, f of 4 and f of negative 4. This is usually the common question at the beginning of these graphics because they want you to find f values. It's going to be FTC. Anytime you're given information about the derivative and you want to find a point, then you're going to take an antiderivative, but you can't take an antiderivative of this graph, but you still can construct the antiderivative with FTC. When you're constructing FTC, I always focus on the three numbers. The given second coordinate, or in this case, the y value, is going to be my number that's getting added. So that's going to be 6. The bottom number is going to be my given x value, so that's going to be 0. And then my want number, or my want x number, is going to be the upper limit of the integral, so that's going to be 4. Here I'm going to write f prime because it's the integral of f prime. And this is my setup of FTC. Now what I do is I have to evaluate this integral. Before we were evaluating integrals with calculators or Riemann sums because that's what the givens sort of entailed. In this case, whenever you have a graph of f prime, you're going to be finding integrals with area. So I'm going to write 6 plus area. Just keep in mind, I don't like to write area right here because you're not taking in the integral of area. You're using area to evaluate the entire integral, if that makes sense. Also, when you're doing integrals with area, just keep in mind that you don't always do the entire area every single time. Here, we're going to go from 0 to 4. So it's going to be 0 to 4. The numbers tell you how much area to do. Another thing to keep in mind is that area underneath counts as negative. Area underneath the x-axis counts as negative. You're also finding the area between the function and the x-axis. So we're finding like this triangle, and this triangle. If you can see, these areas will cancel out, but if you don't see that, that's perfectly fine. Let's just find the areas of these triangles. This triangle looks like it has area 1 because it's 1 times 2 divided by 2. So I'm going to put area in parentheses. So that was this triangle. This triangle will be double that, but it's negative because it's underneath. And then this triangle will be the same as this, so it'll be plus 1. So this one is 6. I still remember to add the number. Now let's do f of negative 4. Still the same setup. Given y value gets added. Given x value goes on the bottom. And then want x value goes on the top, f prime. But here we're in the bad scenario because we have a number in the upper limit that is smaller than our lower limit. Unlike before when we had 4 over 0, or the integral from 0 to 4, here we have negative 4 over 0. And what you have to do is, in order to evaluate an integral with area, you need the smaller limit to be, the bottom limit to be the smaller number. So we have to negate the integral. But my students stop negating the integral. They'll just know that it's minus area instead. So it'll be minus the area. Again, we're finding the area from 0 to negative 4. This is not a great question because, again, these areas cancel. But I'm going to be careful when I do these areas. I'm going to notice that they don't cancel. So I'm going to just find these areas. As I do my areas, I still apply the area rule. That area underneath counts as negative. So this is a negative triangle. Looks like it's 2 times 2 divided by 2, which is 4 over 2, which is negative 2. Negative because it's underneath. And then this one is plus 2. So this one is also 6 because it'll be 6 minus 0. But hopefully you see how to set up these questions. These are the main questions setting up these FTCs. Okay, so the next questions are all the shapes of curves questions, so let's do those. Let's find where this function is increasing and concave down. So shapes and curves are knowing about rules. Every rule has f prime. Keep in mind that this is not a graph of f, this is a graph of f prime, so I don't just like look at where f prime is increasing, for example. I apply a rule. So I like to write the rules before I even start the question. F is increasing when f prime is positive. That's one rule. And then keep in mind that this is a simultaneous question. You're trying to find where it is simultaneously increasing and concave down. So f is increasing when f prime is positive, and f is concave down when f prime is decreasing. There is another rule that says f is concave down when f double prime is negative, but because we're given a graph of f prime, I like to refer to f prime as much as possible, which is why we're going to do the f prime decreasing rule instead. So when I look at this graph, I just need to see where is it increasing, where is my f prime graph positive, because that's where f is increasing, and where's my graph f prime graph decreasing, because that's where f would be concave down. So when I look for this graph, I'm going to look at where's the graph simultaneously above the x-axis and going down. So it looks like it's this portion right here, 0 to 1. And that's that. Okay, let's quickly do the other questions. So let's cover this up. Let's do rel min or max, or local min or max. So again, it's knowing about rules. I don't look for a relative min of f prime. I look at it for f. So when I look at these graphs, they're not going to look like rel min or maxes because we're answering a question about f. But you use the rules. F has a rel min when f prime goes from negative to positive. F has a rel max when f prime goes from positive to negative. So when I do this question, let's do rel min first. Here my graph is negative and then it becomes positive. So this is the rel min. X equals -2 is the rel min. Because I'm going from negative to positive. Let's do this question right here. F has a rel max at this number right here because we go from positive to negative. So that looks like it's at x equals 1. And we're done. Just knowing and using my rules. Similarly, let's do inflection point. So there's a rule that says f has an inflection point when f double prime changes signs. But again, I don't like to use that rule because I am given a graph of f prime. I use the f double prime rule when I can actually take derivatives. So in this case, I'm going to be using the f prime rule, which is the following. So f has an inflection point when f prime goes from increasing to decreasing, or vice versa. So I'm going to take my graph, and it looks like f prime goes from increasing to decreasing at 0. Keep in mind, it's not 2, which is the y value here, it's 0. And then it goes from decreasing to increasing at this number, which is 2. So that's my inflection point answer. And finally, I'm going to do E now. So with E, I'm going to do abs max or min. Let's do it from, if this is my graph, let's do it from whatever these numbers are. So from -4 to 4. So before we even look at our graph, let's try to write our 3 steps. First step is locate. So it's f of x. And again, it's going to be FDC. We actually found some f values earlier, so it'll be the same formula. We're going to add 6 because that's our given y value. So it's going to be 6. Then our given x value is 0, so we're going to put 0 in the bottom. And then we're going to leave this as x, though, and not, for example, 4, -4, because we want to leave this as a variable because we want to plug in numbers into it. So I'm going to leave this as f prime. Second step is critical points, taking the derivative. The derivative of f, of course, is f prime, setting it equal to 0, and using our graph. Before, we used the calculator to find points, and now we're going to use a graph because the graph is given. Here's my graph of f prime. Looks like it is 0 at -2 and 1 and 3. So it looks like we'll have multiple numbers in our table here. Let's start constructing that table. Let's leave some room. Let's go right here, x and f. So we're going to include -4 and 4 because that's our endpoints. And then we're also going to put these values into there as well. Okay, so we actually have done some of these. First off, f of -4 we found to be 6, and also f of 4 we found to be 6. So I'm not going to do those again. So let's take these individually. I actually like to do the bottommost numbers because those are the numbers you don't have to flip. So if we plug in 3 here, remember that when we find these values, it's just going to be 6 plus this integral, which will be area. So it'll be 6 plus the area. So if I have this right here, if I plug in 3, it'll be 6 plus the area. So it'll be this triangle and this triangle. But this triangle is considered negative, so it'll be 1 minus 2. So it'll be 5. So that'll be 5. When we plug in 1, it'll be the area from 0 to 1. 6 plus the integral of 0 to 1. So it'll be just this triangle. So it'll be 6 plus 1, which is 7. And then when you plug in -2, it'll be 6 plus the integral -2, 0. And again, just keep in mind that when you plug in a smaller number on the upper limit here, you have to negate the integral. So it's going to be 6 minus the area instead. From -2 to 0. This triangle has 2 units of area, so it's going to be 6 minus 2, so it'll be 4. So if we're doing abs max, looks like our biggest value in this table is 7. So the abs max is 7 at x is equal to 1, and the abs min is 4 at x is equal to -2. And hopefully that all makes sense. That concludes our stream for today, unless you have any questions. We practiced FRQs of each type, graph, table, particle motion, and rate out. So I think this was a pretty good review. So I'm going to sign off for now. Hopefully this makes sense. We actually also have videos for all of these FRQs that I made during the pandemic a long time ago. I have 11 videos for each FRQ, so it goes more in depth. It goes one overview FRQ for each FRQ, and then it has 10 example FRQs for 10 different videos where we go from difficulty 1 through 10. So you can check those out if you want some more help with these FRQs. But until then, thanks for watching, and I'm going to call it a day.